All right, good morning. This is Mr. Cranier. We're going to be talking about benchmark 29. It's a brand new unit in similarity. And this benchmark is called dilations. So we're going to go ahead in this benchmark. We're going to draw the dilations, and we're going to draw the dilations in a coordinate plane. And we're going to use our GeoGebra website to help us with that. For our first key concept here on dilation, here's going to be our center point C, and this is going to be our first image, and let's just call it L, M, and P, triangle L, M, P. This image, we'll call this our the image for LMP. So this will be our L prime, M prime, and P prime. It's the same image, however, it's enlarged 2.5. And we'll start at the center. We'll say that the distance from C to P is 4 units. And from the distance from C to P prime will be 4 times 2.5. We'll call that 10 in that case. There's some specifics here that we'll talk about in the next examples. First example, we're going to draw a dilation. So what we want to do is we want to copy the trapezoid PQRS and the center point at point C. Then we're going to use a ruler to draw the image of the trapezoid PQRS under a dilation with a center C and a scale factor 3. So in this example, when you dilate something, it's either going to get enlarged or it's going to be reduced. Since it's a scale factor of 3, it's going to be enlarged 3 times. So what we want to go ahead and do is we want to go ahead and draw. You want to draw a segment over here, or array CP. We want to draw array CQ. We want to draw array CR and array CS. And it should look something like that. So when you draw using a ruler, just draw it out. And then the second thing you want to do here is you want to go ahead and draw 3 units from C to Q prime, C to P prime, C to S prime, and C to R prime using a ruler. And this is what your trapezoid will look like. This is going to be your original image, and this is going to be your copied image. All right, if you have any questions, please let me know. This first guided practice, which diagram shows the dilation image of triangle LMN with a center C and your scale factor K is equal to 1/3. So you have your image LMN. There goes your image LMN. And in this case, your image is going to be reduced by 1/3. So it's going to be 1/3 of the original image. So is it going to be letter A, B, C, or D? All right, good luck on this. And again, if you have questions on dilation, please let me know. Number 2, we want to find the scale factor of this dilation. All right, so let's go ahead and let's read this carefully. All right, so to create the illusion of a life-sized image, puppeteers sometimes use the light source, which this will be our light source here, to show an enlarged image of a puppet projected on a screen or a wall. So here goes our image, and here goes the projection in the background. Suppose that the distance between the light source, L, and the puppet. Hey, honey, wait up! All right, so for example 2, we want to find the scale factor of a dilation. In this particular question, we want to create the illusion of a life-size image. Puppeteers sometimes use light source to show an enlarged image of a puppet projected on a screen or wall. Suppose that the distance between the light source L and the puppet is 24 inches. So right here, we're going to just mark down 24 inches. All right, from L to P. To what distance does P to P prime have to be? So we're going to try to figure out what that X value is. That'll be our goal. And we know that how tall the shadow is from from I prime to M prime, which is the projected image, is going to be from there to there. It's going to be 49.5. And there's going to be a 9-inch puppet, and here's our puppet right here from I to M, and we'll say that that's 9. All right, so the first thing you want to do here, we want to find out what the scale factor is. So I'm just going to put that over here. So the scale factor, K, is going to be that 49, the bigger image, 49.5. Divide that by your 9, and then you guys can calculate that. So find the scale factor, and that's going to be 5.5. All right, nice. And then what you want to do next is you want to find out the distance from the light source all the way to the projected image. So what we're going to do is we're going to find L, the distance from L to L prime. So it's going to be 24 times your scale factor, which we have 5.5. Right? And when you guys plug that into the calculator, you're going to get a distance of 132 inches. And that's going to be from the light source to the image projected. Now, all they're asking for is to figure out what this X. So we're going to do some real simple math here. We're just going to subtract the distance for the total to 24 inches from the light source to the P. And that will give you from P to P prime 106 inches distant. Okay, so let's put down from P to P prime. So they're asking us again, to what distance is P prime? The distance is right over here. It's 106 inches. I'll take some time. Again, when you're working through this, make sure you find the scale factor and you multiply it to the distance from L to P, whatever that distance is subtracted from the difference here. Good luck on the next problem. Let me know if you have any questions. See ya. Example 2, guided practice. Pretty much the same type of example from the last example. So if you want to go ahead and go back and take a look at how we formatted that and how we set that up, please do. Number 1, find out what that scale factor is. You already have the 6-inch puppet, and then you have the 54-inch projection. You already know the light source to the puppet, and your goal again is to figure out what distance should you place the puppet to the screen. So good luck on this. Let me know if you have any questions.